All right, now we're going to look at some exponential models, and specifically, this is going to deal with compounded interest. So there's two types of compounded interest. Start with the first one. This is compounded n times a year. So that's a specific number of times every year. And the formula for that is A equals P. I don't know what that's about, but okay. A equals P, 1 plus R over N to the NT power. And what these letters stand for, A is the account balance. P is the principal investment. R is the interest rate. T is the time. And N is compoundings per year. So what we're talking about here is making interest on top of interest, or getting charged interest on top of interest, depending on whether you're the borrower or the loaner. And unlike simple interest, where you get the same interest every year, it grows over time. If you ever had a credit card, bought a house, bought a car, anything like that, you're kind of familiar with how this works, even if you don't get into the minutia of the formulas and things. You still have an idea about paying interest on top of interest, and that's why you got to pay faster than the interest accumulates to pay it down. Now, some common phrases for N here and what their value is. So if something says annually, N equals 1. If it says semi-annually, N equals 2. Quarterly, N equals 4. Monthly, N equals 12. Weekly, N equals 52. And daily, N equals 365. Again, we're not going to worry about leap days and all of that. This is just the numbers we're going to use when we use those particular phrases. So that's one type of interest. The second type of interest, compounded interest, is compounded continuously. And that formula is A equals PE to the RT power. Again, A is the account balance, P is the principal investment, R is the rate, T is the time, E is that Euler's number we looked at before when we talked about bases and how you can use the second button on your calculator, and ln will usually give you that e to the x function to do that. So real quick, we're just going to kind of do an example, a couple example problems here. So let's say $2,000 is invested for 20 years at a rate of 4.5% interest, 4.5, and is compounded and we'll do quarterly, and we'll do continuously. And see the difference. So anytime you run into one of these problems, my first suggestion is write out the formula you're going to use. So this is a specific number of times for quarterly. Just going to write out the formula. Then take a step and fill in all the values you know. So 2001 plus, my rate is 4.5%. So turn that into a decimal, move the decimal 2 spots to the right. That's going to be 0.045 over quarterly means n equals 4 quarters in a year. So 4 times 20 years. And then I would just put that in my calculator. So now some calculators, you just type it out as it looks. I'm using my calculator on my computer here, so it's going to be a little bit trickier. But if you have an older scientific calculator or lower value one, lower cost one, I should say, not value, but lower cost, it may be something similar to this. So what I'm going to do is start with my parenthesis 1 plus 0.045 divide by 4, close that parenthesis up, raise it to the power of parenthesis 4 times 20. I could just put 80, but I'm just going to do it this way. And then I'm going to go ahead and set equals times 2,000. And so this comes out to be approximately whoops, lost it. Let's get back to that one. $4,894.55. 48.94.55. 48.94.55. We're going to round it to the nearest cent. Don't round it to the nearest dollar unless you're told to. And make sure you actually do round it to the nearest cent. All right, so that's compounded quarterly. If I did the same information, but this time was compounded continuously. So continuously, quarterly is like every 3 months or so, they do a calculation, figure out how much interest you get, put that in the account. Next quarter, they calculate your new amount with that other interest on there and calculate a new interest, put all that in there, and so on. So that's how that works. Continuously is like if this was always recalculated. It was always calculating, recalculating, adding the interest on, adding the interest on. So what happens is the more times you do it a year, the smaller percentage you actually use. The 4.5% is for the whole year. If I do it 4 times a year, you take that and you split it into 4 pieces. And you do that little percent each time. So if you were to just pay off the interest, the whole year would be 4.5%. But it actually comes out to be a little bit more because of the compounding. You're building interest on top of interest. So, but because you're doing the more you do it, you do a smaller percent. You kind of got things more times per year, but smaller percent, and they hit a maximum point. And that's the continuous, where it's calculating all the time, but it doesn't, increase without bound. There, it is relatively close to what we're going to get for that first answer. So let's put our numbers in here, and we'll do a calculation. Again, rate is 0.045. Our time is 20 years. Okay, let's put that in our calculator. Again, this calculator does things a little different. I'm going to have to do the exponent first, and then I'm going to do the e. So parenthesis 0.045 times 20, close that up. Second, and then where the ln button had been, e to the x, times 2,000. And 49, 19, 21. 49, 19, 21. So that's more, because the more times you calculate it per year, the more interest you're going to get. It's more, but it's not like 100 times bigger. This is this PERT formula is oftentimes used as a point estimator, just to kind of give people an idea about where they're going with that. All right. Hello, where's my marker? Okay, there we go. If you need to find P, the principal investment, just moving things around, P is going to equal A divided by all that stuff that was attached to P, right? Just divide it over to the other side. Or for the continuous situation, A equals A divided by e to the RT is what equals P. So that's why you could calculate that. And you can stop the video now, but I'm going to go ahead and mention something else related to this. Well, never mind. It's not relevant to today. So I'm going to stop the video here, and we'll talk about, next thing up is logarithms.